Here's some practice. Here's another curve of the derivative, and can you get an idea of what's going on with the original function? So pause the video and copy down the graph and mark it up according to what you can figure out. Okay, you probably figured out that from here on over, we'd say f prime is positive. So what can we say about f? So f, the original f, is increasing. From here backward, f prime is negative. So the original f is decreasing. What can this tell us about the original f hitting a local min or local max? Take a sec to think about that while I write down the question. All right, so you've probably been thinking about it and saying, well, let's do this here. At that x value, the original function has a flat tangent line because the derivative is 0. Over here, the original function is increasing, so you've got some kind of curve like that. And over here, the original curve is decreasing because f prime is negative, so draw some kind of curve like that. And what does that tell you about whether this spot right here where f prime is 0 is a local min or local max? Looks like it's a local min to me, right? So what can we say caused that? Well, we had f prime negative, and then f prime was 0 briefly, and then f prime was positive, and we got a local min. So f prime went from negative to positive as we moved left to right. So let's summarize that. F prime went from negative to positive, hitting 0 in the middle, that's what we mean. We don't mean jumped clear from negative to positive territory. So does the function, the original function for this graph, have any local maxes? Well, we don't see, so local max would usually have f prime equals 0, unless it had f prime dne, but we don't have any non-existent derivatives here. F prime is never 0 again besides that one spot, so there's no other local mins or maxes. It's not clear what's going to happen out here. Is that function going to cross the axis? Is that f prime going to cross the axis or not? We don't know, but we don't have any evidence here of any local maxes. So we can take this idea and call it something official sounding, like the first derivative test. And we call it that because it's a test involving the first derivative rather than the second derivative. It's also the first derivative test that you learn. It's a little bit of a coincidence maybe. So we can say basically what we just said there. If f prime goes from negative to positive, again, just to be clear, we're talking about left to right. As it crosses the x-axis. That is f prime being 0 there. Then f has a local min right there. That's what we just figured out. Anything wrong with that statement? Well, it's a little ambiguous. What did I mean about it? I meant f prime, right? As f prime crosses the x-axis. And then what's the opposite statement for a local max? Go ahead and write that down. Try writing it on your paper while I'm writing it here. If f prime goes from positive to negative, again left to right, as f prime crosses the x-axis, then f, the original f, has a local max there. Now we aren't saying whether it's a global min or max because we don't know how this function behaves anywhere else. So it's hard to guarantee anything, but we're pretty sure it has a local min or max there.